For the second video of this video series, what we will be talking about is the ways that we can charge an object. So keep in mind what we said on the first part of the video, or on the first video of this video series, is that we said that the object is charged as a result of the motion of the electron. And when we have a different number of electrons in comparison to the number of protons, then the object is charged. We saw the general law of charges, that is, like charges will repel, and unlike charges will attract. In other words, same charges will, positive or negative charges to objects that are positively or negatively charged, both. Like they're either both positively or both negatively charged, will repel. And if they are opposite, so one is positive and the other one is negative, or vice versa, then they will attract. The second principle that we saw is that is known as the conservation law of charges, where charges are not destroyed, are not created, but they are moving from one object to the other. And now we know that what it is moving is the electrons. Now, there are three different ways of charging an object. The first one is charging by friction. So what is happening when we are charging by friction? We are rubbing two objects, or one object with another one. So let's say we have an ebonite rod that becomes negatively charged when is rubbed with a fur. So the explanation that stands behind this is based on the model of the electrical structure of matter. An atom, as we mentioned even on the first part of the video, holds electrons and have electrons and protons. Protons are in the nucleus, and electrons are in the on the shells of the element, and then those electrons are held into place by the electrical force of attraction between the positively charged nucleus and the negatively charged electrons. Some atoms, or combination of atoms, have higher force of attraction. So now when the ebonite, let's say, and fur are rubbed together, work is done on the electrons. So therefore, the kinetic energy of the electron is increased, and then therefore those electrons are is having a higher speed, and then they are captured. The electrons are captured by the atoms of ebonite, which exert a higher force of attraction than the fur. So now, in this case, after rubbing, the ebonite that has the excess electrons becomes a negatively charged, and the fur that has a deficit of electrons becomes positively charged. This is a picture of what we said. So the fur and the ebonite, as you see here at picture A, what is happening is the number of electrons, or positive and negatives, is the same. And then on picture B, the number of negatives is higher than the number of positives, which makes the ebonite negatively charged and the fur positively charged. The second type of charging, or way of charging an object, is induced charges, or charging by induction. charging by induction. As you see here, what is happening in the word induction is saying that you do not have, you are not in contact with the object that you are charging. So the charging by friction, you have to rub actually the for into the road so that the exchange or the motion of the electrons is happening, making one positively charged and the other one negatively charged. But what is happening during induction is that the two objects are not in contact with each other, but as a result of the becoming close to each other, then a distribution of the electrons is happening. A very common or typical explanation of the induction is the electroscope. So I will bring some pictures here and then explain them better with you. Okay, so this is a picture of an electroscope. And as you see here, the electroscope has a knob. There's a round shape here. And then it ends up with usually two gold leaves. So gold, because gold is the best conductor, and it is very light. So now on this case, on picture 1, what do you see is a neutral electroscope. You notice that it is neutral because the number of positive is the same as the number of negatives. And then another indication is that the two leaves of the electroscope are calm or parallel to each other. However, now what do we do is in the second diagram, we see that, or we add close to the knob of the electroscope, we add a negatively charged rod. We see that is negatively charged because the majority, and in this case all of them, are negative charges. So what is happening now? We put the negatively charged rod near the knob of the electroscope, and now based on the general law of charges, this negatively charged rod will attract positively charged, pushing away the negatively charged particles in the electroscope. And as soon as they are reaching the gold leaves here, being two same or like charges, they will repel each other. And this is the indication that the electroscope is charged. Okay, when you see that the gold leaves are apart from each other, then the electroscope is charged. So you see now, because this is interesting, you start with a negatively charged rod. The knob becomes positively charged because negative is attracting positive, pushing away the negatives. So the leaves are becoming negatively charged. But when you see the number of electrons and or number of positive and negative charges in the electroscope as one whole thing, it is still a neutral number. So there is nothing that is taken away from the first step, that is starting with a neutral electroscope. So the leaves becomes a negatively charged, and therefore they will repel each other. But the the electroscope as a whole is neutral. And those leaves of the electroscope will stay charged, meaning that will stay away from each other because there is a repulsion force for as long as we keep the rod close to the knob of the electroscope. When we take away the knob of the electroscope, then the redistribution of the charges is happening again, and then negative charges are going back to the knob of the electroscope, and you see an even distribute charges, and then again the electroscope is neutral, because even though that when we put the rod near the knob of the electroscope, the leaves are charged and with the same charges. This is why they are apart from each other, repelling each other. But when we take away the rod, then the charges will be redistributed again. And then we will have the leaves going back to the original position, meaning that, or indicating that the electroscope is neutral. Or exactly saying the leaves of the electroscope is neutral, because even on the case where the distribution of charges is happening, still the electroscope as whole was neutral. But now the leaves of the electroscope are neutral. So this brings us into another example. So let's suppose that we have a small sphere that is neutral. Okay, so meaning we will write or express the fact that we have a neutral pit ball by writing the same numbers of positive as negative. So positive, negative, positive, negative, positive, negative, positive, negative, positive, positive. Okay, so this is a neutral pit ball. And now what do we do is we close to the pit ball, we place a rod that is, let's say, positively charged. So now what is happening here, based on the general law of charges, this positive one will attract negative and will push away positives. So now what do you have here is the pit ball now is becoming more negative in this side, in this area here. There are some positives around, but here is more negative in area A than in area B. So it is a redistribution of charges. Positive, positive. Okay. Now, since now we have more negative than positive on area A, then based on the general law of charges, the rod and the pit ball will interact between each other. So therefore, what will happen is that the pit ball will experience a attraction force. Okay, attraction force. Attraction force. So then what do you see here is that the pit ball is interacting with the charged rod and making it coming close to the rod. because this is becoming, this area here is becoming negatively charged, and this is positively charged. It's becoming positively charged. But as soon as you take away the rod from the pith ball, then what you will notice is it will happen again, a redistribution of the charges, and then you will be on the picture here. Okay, this picture here. So as a whole, the pith ball stays neutral, but there is an interaction as a result of the redistribution of the charges under the presence of a charged rod near a neutral object. But as a whole, the pith ball again stays neutral because the number of electrons is equal to the number of protons, and there is no motion. It's a redistribution of the charges within the neutral object, making this type of charges charging by induction. The third type of charges that we can charge an object is charging by conduction. Charge by conduction. So what we have on this case is that the two objects are in contact with each other. So what is happening when they are in contact with each other, the charges are distributed along the two objects. And this will emphasize again the conservation law of charges. So let's suppose that we have two objects, one that is positively charged with a positive of, I will say 40, so object 1, and object 2 that has the same size and material composed that is positively 8 charge. So now 8, we will say 8 coulombs, 8 positive 40 coulombs. Okay. So now what is happening in this case? The charges are evenly distributed along the surface of both of them. They have the same. They are two spheres that are have the same composition and the same material and the same shape, I should say. So this is the first step. So 1. And then what is happening now is, for a moment, either with wiring conduction or with contacting them between each other. So object 1 and object 2 are in contact with each other. And this again may happen by placing them in contact, as you see here on step 2, or by just adding a conducting wire, like a copper or gold wire. Now, what is happening? The two objects together have a charge of positive 48. So the two objects together have a charge of positive 48. But then what we do is we bring them again apart from each other. So now we have object 1 and object 2. And what we notice is that both of them, since they are the same charges, material and size, then both of them will have a charge of positive 24. So this is the third step. And this is now the two charges are equally charged. Now, why or how can we bring this, and how can we find way to calculate and figure out what are the charges after the contact with each other. So if we have a charge 1 that is, let's say, for simplicity, let's say positive 24 coulombs, and we have an object that is identical in shape and material as a negative 12 coulombs. So what will happen on this case? Remember what we said. Now we have an object 1 that is positive 24 and an object 2 that is negative 12 coulombs. Okay, so they are apart from each other. And then what do? Is we put them in contact with each other. So object 1 and object 2. Now what do you see here is the same as the bank account. So you have positive 24 and someone is in debt of $12. So now you say that, okay, let's have a combined account now. That means that the two accounts will be combined together. And then is a one piece here. What you will have is positive 12 coulombs. And what do you do now is you separate them again. So object 1 here and object 2 here. And each of them will have the same. So positive 6 and positive 6 coulombs. The way that we calculate this is that when they are in contact, conduction charges calculation, is that Q1 prime is equal to Q2 prime, and prime means after they are in contact with each other, will be Q1 plus Q2 divided by 2. So on our case, it will be Q1 prime equals to Q2 prime equals to positive 24 plus negative 12 over 2 equals to positive 6 coulombs each of them. And this is how we calculate when they are positive or negative. It doesn't really matter. What do we have to keep in mind is that we have to add the charges that we have. So let's suppose that we have an example like this, that charge 1 is a negative 14 coulombs and charge 2 is a negative 24 coulombs, and now they are in contact with each other and then they are separated. What is the new charge 1 and the new charge 2? So what we are dealing here is the charging by conduction, and then the two charges after the contact will have the same charges, and this will be Q1 plus Q2 over 2. So it will be negative 14 coulombs plus negative 24 coulombs divided by 2, and negative 14 plus negative 24 will be equals to 38. So Q1 prime equals to Q2 prime equals to negative 38 coulombs divided by 2. And when you divide that by 2, it will be negative 19 coulombs. So both objects, that the assumption here is that they are the same materials, same size, will have a charge of negative 19 coulombs.